We're going to look at some word problems. Ones where we have to find minimum or maximum things. So if we can reduce our word problem into a quadratic equation, and we want to find the minimum or the maximum, well, if we were to draw the graph of the quadratic, we know we get a parabola, and the maximum or the minimum would be the vertex. Now, because we know that, we don't actually have to draw the graph, because we know that minimum or maximum will be the vertex. All we have to do is work out the coordinates of the vertex, and we've solved our problem. So we have to read the question carefully though. Sometimes they'll ask what is the maximum area, volume, whatever it happens to be, whereas other times they might say what are the dimensions that give the area, volume. So whether they're asking for the x value of the vertex or the y value of the vertex. This one is just a straight find the maximum value. So if they want us to find the maximum value, and the equation is y equals minus 3x squared plus x minus 5, they're looking for the y value or the x value? Y. Yeah. So the maximum value would be the y value. Alright, well I'm going to use the, well I'll do it a couple of ways. Here I'm doing it by completing the square. And when we complete the square, we usually like it to just be x squared, so I've factorised out the negative 3. Haven't worried about the 5 because it's just to do with the x's. And then it would become x minus half the coefficient of x. So half of a minus a third is minus a sixth. But when I expand out negative 3 times minus a sixth squared, I get, well, I don't get negative 5. What do I get? 1 on 6 is 1 on 36. Negative 3 times 1 on 36 is negative a 12th. So to balance back in, we add a 12th. Okay, we know where we've moved the vertex to. We want the y value. The y value would be minus 4 and 11 twelfths. Okay, so one way we could do it. Personally, I wouldn't have done it that way. I'm going to use that idea of minus the discriminant on 4a. I think that's a lot quicker. So if I work out my discriminant, b squared minus 4ac, we end up with minus 59. So our maximum value will be minus the discriminant on 4a, minus 59 on 4a. 4 3s are 12, so minus 59 on 12. There you go. Same answer, and I think you'll agree, a lot quicker way of getting that answer. Alright, let's actually look at a practical problem. A problem I'm sure you've experienced yourself. You've got this rectangle with a perimeter of 64 centimetres, and well, maybe that's a bit of string and you can move the boundary and change the dimensions of the rectangle, and you want to form up this rectangle so it has maximum area. As I say, I'm sure you're familiar with the problem. So there's our rectangle. I'll give it some dimensions. I'll call one side creatively S. S for side. Now I know the perimeter is 64, so the other side must be 32 minus S, because all the sides will end up adding to 64. Now the area then is a quadratic. S times 32 minus S. In this case, we're not looking for the maximum area, you notice. It's saying what dimensions will have maximum area. So in this case, we want to find the x value, or the axis of symmetry of our parabola. Well, there's 32s minus s squared. Now, if I did completing this square, then we can now see, once I've completed the square, that the dimensions would be 16 by 16. Again, I don't know that I would do it though. I think the minus b on 2a would be a quicker way of doing it. And minus b in this case would be minus 32 on 2a minus 2. And again, you'd come up with 16, I think a lot quicker. So, but anyway, whichever way you prefer. But they were looking for the x value of the vertex. Okay, time to play.